A breakthrough for scientists after they had a 20-minute conversation with a humpback whale.
You've probably heard whales sing before. Long, haunting calls that carry across open water. Scientists have recorded these sounds for decades without anyone really knowing what they mean. But do you know what happened when a speaker was put into the sea and played a whale call? A humpback whale answered. It surfaced, circled their boat, and gave an actual response. She did this for 20 minutes straight, matching every pause, every rhythm, almost like she already understood what a real back-and-forth conversation was supposed to sound like. That single encounter helped launch one of the most ambitious research efforts in modern science. An attempt to use artificial intelligence to decode what whales are actually saying to each other. What that AI found buried inside their clicks didn't just surprise the researchers involved, it forced them to rethink what we believe language is in the first place. So, what exactly is this shocking discovery about whale communication? Let's find out. The whale who answered. The encounter wasn't scientists getting lucky, and it wasn't a fluke. It was intentional. A combined team from the CETI Institute, UC Davis, and the Alaska Whale Foundation had been studying humpback whale sounds for years, long before they ever attempted this specific test. To get an actual response, researchers knew that they needed to play a sound that had actual meaning to the whales. They did not play back some random noise. They chose a sound that already carried real meaning among humpbacks. It's known as a contact call, and it is the closest thing this species has to a spoken greeting. It's also one of the most common social sounds a whale can make, and it did not disappoint. Almost as soon as they played that contact call, a humpback named Twain showed up. She approached the boat, circled it, and started calling back. Dr. Brenda McCowan of UC Davis was one of the lead researchers of the project. She has described this as the first genuine two-way exchange ever recorded between humans and a humpback whale, using the whale's own signals. But the response itself wasn't even the most striking part. What actually stopped the team in their tracks was how precisely Twain matched the timing of the sounds. She kept adjusting the gap between her own calls to line up with the pauses researchers left between playbacks. She was waiting to allow the researchers to play a sound and waiting for her turn to speak. Twain kept doing this over and over, for the better part of 20 minutes. It was like she was used to speaking in the kind of rhythm you'd expect from two people taking turns in a real conversation. That was a mind-blowing 20-minute exchange, and it became a genuine turning point in whale study. It was the first time these scientists had seriously considered the possibility that whales could have a proper language. What this team did not know was that their exchange with Twain had just confirmed what another study had been working towards since 2017. A hallway comment. 6 years before the encounter with Twain, a marine biologist named David Gruber was sitting with a stack of old sperm whale recordings. These whales communicate in short bursts of clicks, with tiny gaps between them. Gruber had listened to these recordings many times before. He did not think there was anything new to be found in them. That was the moment when a colleague with a background in computer programming was passing by and heard the whale sounds. She stopped and made a comment that it sounded like structured code, something you could try to crack with proper equipment. That single comment stopped Gruber cold. It gave him a completely new perspective on things. Suddenly, the goal wasn't just to understand the whales. It was to find out whether there was anything to understand in the first place. However, before that idea could go anywhere, researchers first needed to answer something more basic. Were sperm whale clicks actually carrying information to begin with? To answer that question, you need to know what sperm whale communication even is. Sperm whales speak in short bursts called codas. These codas are tight clusters of clicks separated by precise gaps. Researchers already knew these codas carried information linked to a whale's identity because every group has its own distinct pattern. Young whales aren't born knowing this pattern of codas. They spend their earliest weeks producing rough, incomplete versions until they eventually lock in what scientists call an identity coda. It is a pattern that stays stable for the rest of that whale's life. Similar to how a surname tells you what family humans belong to, a sperm whale's coda tells you its family identity. By the time that hallway comment reached Gruber, scientists already understood all of that. But what nobody had done was analyze those clicks the way an actual codebreaker would. That single hallway conversation is widely credited as the spark behind Project CETI, one of the most ambitious research efforts ever attempted. And it all began because it asked something nobody had considered before. What if whales weren't just making sounds, but speaking an actual language? Answering that question meant building a tool powerful enough to crack a code nobody had ever tried to read. That is where artificial intelligence was put to use. The AI Whale Translator. Project CETI is one of the biggest marine research programs ever initiated. It pulled together scientists from MIT, Harvard, UC Berkeley, and more than a dozen other institutions into a joint effort toward a single shared goal: build an artificial intelligence system trained specifically to interpret animal communication instead of human speech. It sounded simple enough, but when the plan was put in motion, the first obstacle was more complicated than anyone expected. How do you gather enough authentic whale recordings to actually train a system like that? The team set up their main research base near the Caribbean island of Dominica. That location wasn't chosen at random. Marine biologist Shane Giro had already spent decades observing whale families in those exact waters. This gave CETI's scientists an enormous head start. Researchers already knew individual whales by name, understood their family structures, and had already mapped much of their social world. What they still needed was the kind of detailed data an AI system actually requires to learn anything meaningful. So the team installed networks of underwater microphones along known whale migration routes. They also attached specialized suction cup tags directly to individual whales. Each tag carried several microphones capable of isolating one whale's voice inside a crowded group. The goal was to capture everything happening around that sound in the same instant, such as who was speaking, who they were speaking to, and what was actually going on in that specific moment. All of that context matters enormously if you're trying to understand how the meaning of words shifts from one situation to the next. After thousands of recordings, the project finally had enough material to start producing real answers, and those answers genuinely caught the research team off guard. What the AI showed. For years, the working theory in whale research had been fairly simple. Sperm whales used roughly 21 distinct coda patterns. Each coda pattern carried a single fixed meaning. Think of it as similar to how a traffic light uses red, yellow, and green as three separate signals that never change. But after analyzing thousands of whale recordings, Project CETI's AI system identified something different entirely. Whales speak in 156 distinct codas, and none of them carried one single fixed meaning. Individual codas changed meaning based on 4 separate features layered together. The research team chose to describe these features using musical terminology: tempo, rhythm, rubato, and ornamentation. Tempo refers to how quickly or slowly the clicks come out. Rhythm describes the specific spacing between them. Rubato covers small timing shifts that add something close to emotional inflection. Ornamentation refers to extra clicks woven into the middle of a pattern that change its overall shape. This was the first message that scientists received from using artificial intelligence to study whale language. It has genuinely reshaped how scientists think about animal communication. Because these features had long been treated as a defining trait of human language specifically, no other species had ever been documented using anything resembling this kind of layered structure. When Project CETI published these findings on whale communication in the journal Nature Communications, it was the first ever study of its kind. It broke all preconceptions that scientists had about animals and their ability to communicate. And the study didn't stop there. CETI researchers also noticed something else worth pausing on. The same coda type didn't always sound identical every time it appeared. Some of that variation seemed tied to the surrounding social situation. This hints at the possibility that whales might genuinely adjust how they communicate depending on context. It is the same thing as a human changing their tone depending on who they're talking to. Researchers have been careful to describe this as an area of ongoing study rather than settled fact. However, with the kind of evidence piling up, it is hard to think of it as anything other than that. And Project CETI wasn't done yet. Their next discovery pushed things into even stranger territory. Sounds like vowels. Building directly on the 2024 findings, CETI linguist Gasper Begusch approached the same recordings from a different angle. He stopped focusing only on the pattern of clicks inside a coda. He slowed down the recordings and examined the precise acoustic shape of the individual sounds themselves. What emerged were two distinct sound patterns that behaved strikingly like human vowels. One resembled the ah sound in the word father. The other resembled the e sound in the word see. Researchers also found evidence of the whales gliding or transitioning between these sounds. Exactly how human speech flows from one vowel into another. At normal listening speed, none of this is audible. These sounds simply register as fast clicks. Only when you slow them down to match the pace of human speech do these vowel-like qualities become clearly noticeable. That detail matters more than it might sound like at first. Sperm whales are in no way similar to humans in anatomy. They do not have a lowered voice box. Their entire vocal system evolved for a completely different purpose: echolocation. This is a process that involves sending out sound waves and reading the echoes that bounce back to build a mental picture of pitch-black surroundings deep underwater. Similar to sonar machines, are two species separated by hundreds of millions of years with no shared evolutionary path at all. They have independently arrived at communication solutions that mirror each other. As MIT researcher Dr. Daniela Roos put it, these results show there is far more underlying complexity here than scientists had previously assumed. There's also an unsettling detail that tends to get glossed over. The same organ system responsible for producing these delicate, structured, vowel-like sounds is also the source of the sperm whale's hunting clicks. These are among the loudest sounds any living animal produces. The same biological structure capable of something resembling gentle speech is also capable of functioning like a weapon. So, if whales really do have a structured communication system, what is actually being said? Scientists have found specific, repeatable sound structures and rule-bound patterns that shift depending on context. There is evidence of real back-and-forth timing between individual whales. Researchers aren't guessing that whales might be communicating. They're pointing at hard evidence, precise timing, patterns that change with social context, and click structures that behave like vowels. The open question researchers are chasing right now isn't whether something is being communicated. The real question is, what's being said, and to whom? They are building towards something closer to an actual working vocabulary. The foundational moment in all of this language research and translation effort has already happened. For the first time in history, humans have listened closely to another species and recognized that what they are hearing has the structure of language. That distinction matters enormously because sperm whales connect to humans in ways very few other animals do. Biologists have already documented behavior in whales that points toward complex, culturally transmitted communication. Whales also show real emotional depth, and that's exactly where this story gets harder to look away from. Grief, culture, and warning signs. Different sperm whale clans function as entirely separate social groups that don't mix. Each one has its own distinct coda style, almost like a regional dialect. Young whales appear to learn their specific clan's style rather than being born already knowing it. This is the same as a child absorbing the accent and vocabulary of whatever community raises them. Emotional depth has been documented across many whale species, not just sperm whales. And one of the clearest examples on record actually involves a different species entirely. A southern resident orca named Tahlequah. In 2018, off the Pacific coast, Tahlequah gave birth to a calf that survived only about 30 minutes. Most animals in that situation would leave the body and move on. Tahlequah didn't. She carried it with her for 17 days, across more than 1,000 miles of open ocean. Other females from her pod stayed close to her for much of that period. A level of sustained, shared grief response that researchers say closely resembles human mourning. Similar grief behavior has now been documented in at least 20 different whale and dolphin species worldwide. And a very different kind of coordinated behavior has also drawn attention off the coast of Spain and Portugal since 2020. A distinct pattern of orcas targeting the rudders of sailing boats has spread rapidly through a local population. Researchers believe it likely began with a single individual and then spread through social learning to others in her pod. Eventually, it started appearing in unrelated groups as well. Scientists studying it have avoided claiming certainty about exactly why it started. But what they are saying is that it's further proof of just how complex and sophisticated these animals are. Across sperm whales, orcas, and humpbacks alike, one thing keeps showing up in the research. These are species that transmit detailed information across social groups, sometimes even across enormous distances, and they depend on sound to do almost all of it. That dependence is exactly why what's happening in the ocean right now has researchers increasingly worried. When the ocean goes silent. Once researchers understood just how sophisticated whale communication actually is, a problem that had always existed suddenly looked far more serious. That constant mechanical noise actively interferes with their ability to communicate at all. For sperm whales specifically, communication isn't just about socializing and survive in complete darkness thousands of feet down. Studies have already found sperm whales with permanent hearing damage and measurably elevated stress levels tied to chronic ocean noise. Such negative responses to noise are being seen because disrupting a sperm whale's ability to communicate doesn't just isolate it. It threatens its ability to survive. But to put it in perspective, picture losing the ability to see or speak with anyone close to you permanently. That's close to what constant noise pollution actually costs an animal that depends on sound for nearly everything. As scientists came to understand all this, the conversation went beyond biology and linguistics. It began shaping how governments and legal systems think about whales as beings. In 2024, Indigenous leaders in New Zealand and the Cook Islands signed a formal declaration recognizing whales as legal persons with defined rights. Project CETI has since partnered with legal experts to explore what this deeper understanding of animal communication could mean for animal rights law. CETI linguist Gashper Begush has put it plainly. This research raises real questions about whether language should be treated as something uniquely human, or something that exists on a continuum across many species, and what that shift should mean for how we treat the animals living alongside us. So where does all of this actually leave us? Scientists have confirmed the first and arguably most important message: a structured, rule-based communication system built from smaller, combinable parts. It contains sounds that function like vowels, layered with patterns that shift depending on context. What they haven't confirmed yet is a specific translation of what any of it actually says. Between proven structure and unproven meaning is exactly where this research currently stands. For most of human history, People assumed the ocean was essentially silent beneath the waves. AI-assisted research has now shown that sperm whale communication has the genuine structure of a language. And for the first time, researchers know exactly what they're listening for. What do you think we'll learn once scientists finally crack what whales are actually saying to each other? Let me know your thoughts about this in the comments below. And if you enjoyed this video, make sure to like, subscribe, and turn on notifications so you never miss the next mystery we dig into. Thanks for watching, and we'll see you in the next video.